Welcome to Shree Learning Academy. Our today's topic is Understanding Data Execution Prevention. So let's get started. Data execution prevention, often abbreviated as DEP, is an essential safety measure integrated into operating system. It aims to protect your computer system from security threats by preventing certain types of malicious software from executing actions that could harm the system. DEP represents a type of memory protection technology that distinguishes between sections of memory designated for code execution and sections designed only for storing data. This distinction makes it harder for harmful software like viruses or worms to take control of your computer system. In essence, DEP is like a security guard assigned to ensure that no unauthorized activities are happening within the memory region of your computer system. If something unusual tries to happen, DEP intervenes. The role of DEP in preventing buffer overflows. To understand the role of DEP, we need to understand common cyber attack known as buffer overflow. In simple terms, a buffer overflow occurs when a program or a process tries to store more data in a buffer, that is temporary data storage area, than it was designed to hold. This excess data can overflow into adjacent buffers, causing them to overwrite information and possibly lead to erratic program behavior, system crashes, or security breaches. Consider this example. Imagine you are trying to pour 2 liters of water into a bottle that can only hold 1 liter. Obviously, the excess water will spill over and could potentially cause damage. The same principle applies to buffer overflows. When an application attempts to store more data than the buffer can handle, the overflow can corrupt data, crash the application, or allow the execution of malicious code. This is where DEP comes in. DEP protects against these attacks by limiting where code can be executed. It essentially differentiates the read and write sections of a system's memory. And when a piece of software tries to execute code from a memory section that is meant only for data storage, DEP jumps into action, blocking this execution and thereby protecting the system. How some buffer overflow attacks bypass DEP. While DEP serves as a significant line of defense against buffer overflow attacks, it is not completely foolproof. Some sophisticated forms of attacks can bypass DEP protection. For instance, an attacker might use a technique called return-oriented programming. ROP involves an attacker finding bits of code ending in a return instruction, that is referred to as gadgets, and then chaining these gadgets together to perform arbitrary operations. And these operations are executed using existing executable code, so they can bypass DEP's protection. To make this clearer, think of a DEP as a guard who only allows authorized personnel to enter certain areas. In an ROP attack, the attacker disguises himself as an authorized person by using pieces of authorized codes, so the guard lets him through. The stealthy nature of DEP failure. DEP failures or situation when DEP fails to prevent unauthorized code execution can be hard to identify. The reason is that these violations may not have an official output, log, or report, while some security solution may record memory, abuse attempt logs, not all of them document specific DEP violation. This stealthy nature of DEP failure makes it harder to diagnose the problem, making it a silent threat that could go unnoticed for a long period. It's akin to a security breach happening right under the nose of a security guard with no alarm system in place to alert them. The administrator's role in identifying DEP failures. When DEP is bypassed, the system administrator may notice signs of unauthorized code execution or malware on the system. These signs can vary and may include unusual system behavior, decreased system performance, or unexpected application crashes. The response to such indications should be swift. The first step is to terminate the offending code and remove it from the system. Once the immediate threat has been dealt with, it is essential to identify how the code execution bypassed DEP. If the method used is known, the administrator can install patches or filters to prevent such exploitation in the future. This is much like patching a hole in a fence once you have discovered that intruders are using it to gain unauthorized access. So in a nutshell, DEP is an essential security feature in modern operating system designed to protect the system from certain type of attacks. However, like any security measure, it isn't invincible and can sometimes be bypassed. While DEP has its limitation, it forms an integral part of an effective multi-layered defense strategy. It's critical for system administrators to understand these nuances ensuring that their systems are as secure as possible. Thank you so much for watching this video. Do check out the written explanation on our website and don't forget to take this quiz based on this video. The links are in the description box below. Subscribe to our channel to watch more interesting videos, and if you have any doubts, do let us know in the comment section and we will try our best to solve them for you. For private coaching, do contact us by visiting shreelearningacademy.com or on WhatsApp. See you in the next one.